Welcome to Data Model Integrity. In this lesson, we will cover entity indexes and referential integrity between entities. Stop row. An index is a data structure used by databases to speed up retrieval of data from database tables. In the case of OutSystems, indexes can be used on entities. It is important to know that although indexes can speed up data retrieval, it comes with a cost. Besides taking up storage space every time data is changed, the indexes also need to be changed to match the existing data. This will happen with any kind of data writing, for instance, inserts or updates. Having an index defined over a particular set of attributes will speed up data retrieval when selecting data based on those attributes. Reference attributes are a good example, and that is why those indexes are created automatically. We can create our own custom indexes as well. You should create or modify indexes very carefully. Adding too many indexes can actually cause performance issues, but creating the right indexes can improve performance. Another reason for creating indexes is to avoid duplicates in data. Depending on your data, you might want to enforce that the data of one or more attributes is unique. An example of a unique index would be that for a particular order, only one instance of a product exists. In other words, the set of order ID and product ID is unique in the entity. This would prevent having an order with the same product multiple times. To have an order with multiple items of the same product, the quantity attribute would be the one defining the number of items. Indexes can help us with the uniqueness of the relationship, but we do have something called the delete rule. Attributes that are references to other entities have the delete rule property. This property can be very important since it is applied when we're deleting a record from the referenced entity. Keeping with the same scenario of customers and orders, if we end up deleting a record from a customer, what should we do? Inside of the delete rule, we have three different choices. We can protect, which means don't allow the deletion of the record. That way, customers who still have orders should not be deleted. If we choose delete, then it says delete the record and cascade deletes all the records that it references. If we delete the customer, then we should delete all of the orders as well. We also have a choice called ignore, which doesn't do anything because it will not guarantee the referential integrity. When the customer is deleted, ignore will not protect the order, but it also won't delete it. The order is kept, but there is no relationship because it's ignoring the fact that, although it's referenced, there is no strict relationship between the two records. IL? When we use protect or when we use delete, the relationship that is being created by this rule is enforced by the database. That may cause extra overhead, which may lead us to do some tests to determine the impact of using these rules on performance. We could also do these deletes and protects by actually adding logic inside of code while we're manipulating these entities. The delete rule is there, and these are the different settings that we can use, but the number of different ways to handle this may sometimes cause concern about the performance of those issues. It's up to the developer to decide.